Remote Direct Memory Access, RDMA, enables direct memory access from one computer to another without involving the operating system of either device. This feature allows for high throughput and low latency memory access over a network, particularly beneficial in massively parallel computer clusters. RDMA facilitates zero-copy networking by empowering the network adapter to transfer data straight from the wire to application memory or vice versa. As a result, the necessity to copy data between application memory and data buffers in the operating system is eliminated. These transfers do not burden CPUs, caches, or require context switches, allowing them to occur concurrently with other system operations. Consequently, the RDMA approach decreases latency in message transfer. However, a challenge arises from the fact that the target node is not informed of the completion of the request, known as single-sided communications. Zero-copy programming techniques are beneficial for exchanging data within user space processes or between processes, as well as for handling data within kernel space or between user space and kernel space in operating systems. When a user space process needs to interact with devices or move data between devices, it typically requires system calls executed in kernel space by the operating system. By utilizing zero-copy system calls available in modern operating systems, unnecessary data copies between user and kernel space can be avoided, thereby enhancing performance. Elements like device drivers, file systems, and network protocol stacks benefit from zero-copy versions, improving application program performance and resource utilization. Through zero-copy operations, the CPU can delegate data copies and processing tasks to optimize system resources and reduce context switches between user and kernel space. For instance, sending a file over a network traditionally involves multiple data copies and context switches, which can be minimized or eliminated with zero-copy techniques, boosting efficiency. Particularly in high-speed networks, zero-copy protocols play a crucial role in preventing the CPU from becoming a bottleneck by efficiently managing data transfer, crucial for maintaining communication rates near the link's capacity. Various hardware implementations like direct memory access, DMA, and memory mapping through a memory management unit, MMU, support zero-copy programming by meeting specific memory alignment requirements. Additionally, interfaces in operating systems such as novel NetWare, Linux, FreeBSD, macOS, Oracle Solaris, and Microsoft Windows offer specific system calls that enable zero-copy functionalities in handling user data and file contents. Techniques like RDMA protocols heavily rely on zero-copy methods to streamline data transfer processes. In 2018, RDMA saw increased acceptance owing to enhancements that enabled efficient performance across standard networking setups. RDMA over Converged Ethernet, ROCE, successfully operates on both lossy and lossless infrastructures. Additionally, iWarp facilitates an Ethernet-based RDMA approach at the physical level by utilizing TCP/IP as the transport mechanism, blending the benefits of RDMA with a cost-effective, standardized solution. The RDMA Consortium and DAT Collaborative have been instrumental in shaping RDMA protocols and APIs for evaluation by reputable standards organizations like the Internet Engineering Task Force and the Interconnect Software Consortium. Hardware manufacturers have advanced their efforts toward developing high-capacity RDMA-based network adapters, boasting speeds of up to 100 Gbps. Leading software entities like IBM, Red Hat, and Oracle Corporation have integrated support for these APIs into their latest offerings. Engineers have been crafting network adapters since 2013 that implement RDMA over Ethernet. Noteworthy operating systems like Red Hat Enterprise Linux, Red Hat Enterprise MRG, Windows Server 2012, and VMware ESXi have all embraced RDMA. Furthermore, various RDMA implementations such as the Virtual Interface Architecture, ROCE, InfiniBand, OmniPath, iWarp, and Ultra Ethernet are prevalent. RDMA applications manage access control structures using standardized APIs initially designed for the InfiniBand protocol, but adaptable to other RDMA implementations. Applications execute RDMA operations by submitting work queue entries into the submission queue and receiving notifications of responses from the completion queue through send and completion queues. RDMA can transport data reliably or unreliably, utilizing the reliably connected, RC, and unreliable datagram, UD, transport protocols, respectively. The RC approach ensures request preservation, while UD demands fewer queue pairs when handling multiple connections as it operates in a connectionless fashion, enabling a single host to communicate with any other host using a single queue.